gain is measurement of absolute gain. Measurement of absolute gain. Okay. So here also two identical antennas separated by a distance r. So this is transmitting antenna. This is receiving antenna. That is antenna under test. In the previous case, at the receiving end, how many antennas are there? Two antennas are there. One is standard horn antenna, the other one is antenna under test. Initially, you connect to the standard horn antenna and measure the measurement, and after that, you will detach that and you will connect to the antenna under test. This is happen in direct comparison method. Okay, now coming to the second method, that is absolute gain. Coming to the absolute gain, here only one transmitting antenna and one receiving antenna, that is antenna under test, and compulsorily they both antennas should be separated by a distance r. What is the value for r is equal to 2d square by lambda. R is equal to 2d square by lambda. Okay, so here coming to here, the conditions is, let us consider, for example, let PT and PR represents transmitted power and received power. Okay, so let PT is the power transmitted by transmitting antenna and PR is the power received by receiving antenna. Okay, and let AET and AER represents the effective areas of transmitting and receiving end. Okay, means, so for example, this is my antenna transmitting and the effective area is, for this is AET and for this antenna is AER. Okay, so AER. So next, if transmitting antenna and receiving antenna are of same type, same configuration, then AET is equal to effective aperture area of transmitting antenna is equal to effective aperture area of receiving antenna is equal to GD into lambda square by 4 pi. Okay, we know that the directivity is equal to 4 pi AE by lambda square. Here directivity are calling it as gain. Okay, so from this AE is equal to G into lambda square by 4 pi. G into lambda square by 4. G into lambda square by 4 pi. Okay, so from Friis transmission equation, Friis transmission equation, which gives the relationship between, so Friis transmission equation, very important equation, Friis transmission equation, which gives the relationship between received power and transmitted power, given as okay. So the relation Friis transmission equation is given as PR by PT is equal to AET by lambda square to AER by R square. Okay. So what is this PR? Power received by receiving antenna. What is this PT? Power transmitted by transmitting antenna. What is this AET? Effective aperture area of transmitting antenna. What is this AER? Effective aperture area of receiving antenna. What is this lambda? Lambda is in wavelength. What is this R? R is the star. This is receiving antenna. Let us consider this is transmitting antenna. R is the separation distance between transmitting and receiving antenna. This is given by the Friis, which gives the relationship between the amount of power received by receiving antenna and amount of power transmitted by transmitting antenna in terms of effective aperture areas. terms of transmitting and receiving effective aperture areas. Therefore, PR by PT is equal to, so what is the formula for the AET? You have written this, the formula for AE is equal to G lambda square by 4 pi. G lambda square by 4 pi. Okay, so for transmitting antenna or effective, so it is GD into lambda square by 4 pi. Okay, so it is in the place of AET, I am writing this thing. Okay, so it is GD lambda square by 4 pi. This is for AE. Okay, similarly for AER, it is GD lambda square by 4 pi into, what is the remaining here? Lambda square into R square. Lambda square will get cancelled. Therefore, PR by PT is equal to GD into lambda by 4 pi R whole square. 4 pi R whole square. From this, GD is equal to the gain of the antenna equal to 4 pi R by lambda. 4 pi R by lambda root of R by. So this is how you can calculate the gain by using direct, by using absolute gain method. By using absolute gain method. By using absolute gain method. So GD of gain is equal to 4 pi R by, okay, so root of PR by PT. Okay, so 4 pi R by lambda into PR by PT, where PR is the received power, PT is the transmitted power. PT is the transmitted power. Okay, so this is how you will perform the measurement of gain by absolute gain method. So this is the second. Okay, this is the second method. Okay, so let us go to the third method. Let us go to the